I'm Doug Fairbairn, and it's June 3rd, 2014. So, Fontaine, welcome. Delighted to have you here. Thanks for making the trip out from the East, and delighted to be able to capture your story. During these interviews, I always like to go back to the very beginning, talk about the family life that you grew up in, brothers, sisters, role of the parents in shaping your future direction. And so let's just talk about that. When were you born? Where were you born?
I was born in 1941 in Fayetteville, Arkansas, which is where my family was. I'm the third of four boys. There's 18 years difference between the oldest son and the youngest son.
Oh my.
So I tell people that I'm one of four only children.
Yes.
From 41 to 46, World War II is going on, and my father was in the field artillery, and we traveled around extensively, and he finished the end of the war in Fort Sill, Lawton, Oklahoma, where they were testing some proximity fuses for the field artillery. My father had a PhD in mathematics and taught math at the University of Arkansas, so his math skills made it natural for him to be in the field artillery and compute projectile trajectories.
So he was not actually in combat in Europe
or
whatever,
but he was helping develop. And so our family moved around with him because he went from post to post during the war. And then we settled back in Fayetteville, Arkansas in 1945, late 45, early 46. And my father resumed teaching at the University of Arkansas. My mother was a musician. She loved playing the piano and was a church organist, loved music. They both loved music. They sang. We all sang together as part of entertainment.
Wow.
My father and his brothers grew up in Cane Hill, Arkansas, which is just southwest of Fayetteville, and pretty isolated, and they entertained themselves by singing, among other things. And, but all three boys had very extensive careers. My father was youngest of three. He had a bachelor's from the University of Arkansas, a master's from Harvard College, and a PhD from University of Chicago.
Wow.
My uncle was an MD.
So even he, coming out of Arkansas quite early, had found his way to Harvard.
Yeah, it was sort of the other members of the family had done as well. So growing up, there was an expectation that you'd go to college, that you were expected to go to school and behave and do well, do the best of your ability. I was a medium student. I excelled at things I was interested in and sort of didn't excel at some of the things. I had a paper route, delivered 125 papers every day, 6 days a week in the afternoon, and understood economics because I had to go collect from the customers and pay for the papers, and so the cash flow was...
I did exactly the same thing, only 7 days a week, Sunday morning.
Well, we were in the Bible Belt, so their blue laws existed at that time, so Sunday was a pretty quiet day. Bought a bicycle, delivered papers from my bicycle, rode around. Fayetteville's very hilly, and so riding up and down as and it was a single-speed bicycle, first of all, and finally a three-speed. So played trombone in the band, played in the band through junior high school, and in high school was on the football team. I didn't play very much football, but I was out doing that, and got interested in school government and was on the student council, and junior year was vice president of the student body, and senior year was president of the student body. So I learned Robert's Rules of Order and how to conduct meetings and things.
How to run things.
How to run things. And
have any hobbies or outside activities?
I was a ham radio. There was a lot of surplus World War II electronic equipment and stuff around, and one of the professors at the university took a couple of us under his wing and helped us study for the novice code and learn Morse code and do that. And I eventually assembled a Heathkit receiver and built a homebrew transmitter.
Wow.
But the terrain in northwest Arkansas and where we lived, we sort of lived in a valley. So you could transmit all you wanted. There wasn't anybody listening to you. So, and this is 2 meters became a far more viable thing with repeaters and all that stuff in modern times. But back in the day, I had a 40-meter antenna stretched out the back of the yard, and every time I tried to transmit it, screwed up the television. So my older brother complained bitterly. So all that stuff.
Well, our background is even more similar than I knew. I was also a ham radio operator and had some surplus World War II equipment and built I guess I built the transmitter not from a kit, from scratch or something.
Yeah, I built the transmitter from somebody's plan.
From tubes.
From tubes.
Yeah.
And they used the 6146 transmitting.
I couldn't tell you what I had used, but it's, I still remember what it looks like. I've still got a picture of this huge Navy receiver on my desk.
And so got interested in girls in high school, and I did reasonably well academically, and gave a half-hearted attempt at applying to other schools. Rice University at the time was free, and so I made an application to them but didn't get in, and so the obvious place to go was the University of Arkansas. So I lived a half block from the campus with my father and my younger brother. My mother passed away between my sophomore and junior year, so it was the three of us at home. And started out in mathematics and decided after 1 year that I wanted to study and be an architect, so I spent 2 years studying architecture, and the chairman of the department did me a big favor. He said, "You're the most promising student I have." Oh, how's that? Well, you're always promising and you never deliver. So that and the fact that I was going to get married as a senior, I decided that I ought to pick something that I could earn a living in and enjoy, and so I brushed up my mathematics and then graduated with a Bachelor of Science in Mathematics. My wife was studying home economics, and being married helped concentrate your energies and spend time focusing instead of other things you might be doing. At the same time, got my first exposure to computing in that there was an IBM 650 on campus in the science side of the university, not the business administration. And the 650 is a vacuum tube machine. It's a punch card. It's electronic accounting machine is really what it is. But programmed that in assembly language and did a variety of assignments, first in a course that I took and then later as a member of the staff. And basically stayed with that for the 2 years there. And I got a bachelor's degree and then a master's degree in math at the same time my wife graduated in home economics. So we both graduated and got an offer for a summer job with Continental Oil Company in Ponca City, Oklahoma, and to work on their computer. They had a 709 that they were upgrading to a 7090, and then a 7094. They wanted help making some of the language transitions from Fortran 2 to Fortran 4.
How did you make that connection from
Well, it's
Arkansas
all family. It's one of the people in town's wife was on the math department faculty. Her son was working for Continental Oil Company. I called and I said, might have any possibilities? And they said, sure, come on over. So went and interviewed and got the job, and not knowing what's next. We were going to had applied to graduate school. The University of Arkansas did not have, I wanted to get a PhD in mathematics. And the University of Arkansas didn't have a program for that. So we knew it was leave town, but Ponca City's the next stop, but where from there is up in the air. So we made an application to Purdue, to the University of Illinois, and whatever else I don't remember. And my wife made an application for home economics, and I made an application for math. And she got a full boat fellowship to the University of Illinois to study home economics.
Wow.
So
fellowship to go study economics. What the
home,
day,
home economics.
Home economics.
Clothing and textiles. And I landed an assistantship because of the experience working on the 7090 in the digital computer laboratory.
So what year was this now?
64.
Okay.
So we arrived on campus, and I walked into what was called the digital computer laboratory building full of computer, and it was the ELIAC 2. It was a solid state machine. It was the design targets were to be competitive with the IBM 7030, the stretch computer. It probably was. It had a 52-bit wide word in order to do floating point, and it was 4 13-bit word chunks for instruction set. It had 8,000 of those words in core memory, and half a megabyte of drum storage, and mag tapes. So that was it, and so I got working on operating system stuff and got the assignment to work on time sharing this, because in parallel MIT was working on the Mac project to time share. You had time sharing effort going on IBM 360-67s, PDB-10s, Sigma 7s. So why not put one on this home-built computer? So we eventually got it running. There was no memory protection, so it was not the most reliable of things. But so I did that and did all my schoolwork for mathematics and passed all the exams, two foreign language exams, the qualifying exam and all that. Was ready to look for a thesis topic. And the fellow I had been working for at the laboratory, computer laboratory, said, "We're going to offer a PhD program in computer science. Would you be interested?" And I said, "Sign me up." So he said, "Okay." I said, how much backtracking do I have to do? He said, "Just audit." He knew me from working with me and knew that I knew, had picked up a lot of stuff. And he said, "Well, just
you knew as much about computing as anybody at that time, probably."
He said, "Well, audit these two things." And so I said, "Okay, well, what about a thesis topic?" And he said, "How about using flowcharts as a programming language and use the computer screen, CRT, and the computer and program that, and we're going to do it on a remote computer and have that connected to the ELIAC 2 and actually do the execution on ELIAC 2. And so, lots of stuff that's very commonplace today, but it was a workstation. When it was finally configured, it was about $130,000 worth in 1966 money. The PDP-8, which is a 12-bit word, and you had 256 word pages that you programmed in. So programming is a little all in assembly language, a little contorted. So on the ELIAC 2, it was all assembly language. So by that time, I'd done 3 or 4 different assembly languages. So my theory is once you've done one, the next ones are pretty easy. So I did that and made a movie, which that's what I brought here to you last fall, and stood the examination and gave a demonstration. And of course, the demonstration crashed at the end. They passed me anyway, and I was on my way. So by
this time, this was what year?
67, 68. So I knew I was going to get out in 68, so I started interviewing, get out with a PhD in computer science and interviewing. And what I discovered is that having a PhD in computer science was unusual.
Yeah, that was the first thing I was going to say, is you must have been one of very few people who had such a degree.
I got the second one from Illinois, but mine was in software and his was in some sort of electronic stuff. So I got lots of interview opportunities. I interviewed out here with IBM, out here with Control Data. I got Control Data, UNIVAC interviews in Minneapolis, IBM interview in Watson Research Labs, Bell Laboratories, RCA Labs, and sort of the last interview I got was at Lincoln Labs. And we had a conference about computing on the campus of the University of Illinois in probably late 67, early 68, and Bert Sutherland came from Lincoln Labs and saw what we did, and I came up and introduced myself, and I said, what do you, have you got a job for me? And he said, well, let me check. And so he called back, and I went out and interviewed and got a job offer from them, and it fit. So my wife didn't want to stay in Illinois because it was flat, and the appeal to both coasts were, the differences, and we picked Massachusetts, A, because the job was the most fun job, and B, the four seasons. With living in Arkansas, and Illinois, the seasonal variety is it's stark. It's hot or it's cold. And Massachusetts had all this American history and all the things that went for it. And so we said, fine, we'll take that job. So I showed up in April of '68 at Lincoln Laboratories.
So what was Bert Sutherland doing? I mean, this is sort of a sidetrack at that point.
We were all collectively working on assignment from the what was then ARPA, Advanced Research Project Agency, where Larry Roberts was and Ivan Sutherland were, having been in the same laboratory and done thesis on the same TX2 computers. They had migrated down there and were doing the kinds of things that were magic. I mean, they were making things happen. And so there was a contract with Lincoln to research tools for designing electronic circuits. That the belief turned out to be true, that the complexity of circuits was going to grow, that it would be harder and harder to design circuits, and you needed new tools, new methodologies, new ways of thinking about all this.
Yeah, so I knew that Ivan Sutherland was there. I didn't realize, didn't understand that Bert was there at the same time.
Yeah, he was a group leader, and had, I don't know, half a dozen of us, or maybe more. He had collaborated with people from David Mann, the pattern generation people, and they were building this pattern generator, which is a rectangle on the photomask, and needed some data to drive that. So Bert wrote a program to basically you program the blocks, punched a paper tape, took it to David Mann down the street, and they made reticles. And then we were in the group that I was in. They were designing circuits. They were designing ECL circuits, and were building them at Philco Ford down in just outside of Philadelphia, and testing them. And these were pretty whiffy. I mean, they were high speed. They were 1 microsecond loops through gates and things, which was fast for the time. And so Bert had done that as a way of sort of getting the first connection to David Mann, and then he did an interactive program on using the screen of the TX2 and to sketch rectangles. And then once you build up a pattern of nested cells and things, and then punch a button and generate a tape, and that was how you made the patterns on them. And this was actually used to make patterns for the guys designing circuits. And so I came along, and he said, well, this is the first pancake. You always throw the first pancake out. Why don't you redo the program? And I think we called it Mask Maker. I don't know, but it was. So we did that, and this is on a interactive CRT with the power of the TX2 and all the operating system stuff and all that. So, and I didn't write any of the program. I had a couple of Don Ostreicher, who you may have worked. He was at Adams Associates and did the actual programming. So, but we'd say, here's what about doing it this way? What about the human interface stuff? And built up pretty reasonably capable program. And the laboratory was in the information exchange business. So we went around. We were sent around, a group of us, and talked to all the different semiconductor companies around. We visited Fairchild. We went to Texas Instruments, and talked about what we were doing and listened to what they were doing.
So this is 1968.
Yeah. And we got a lot of interest. TI had a fledgling graphics unit effort, as did Fairchild Semiconductor, using an IBM machine. They were all IBM machines and all fairly expensive lash-ups and no commonality, no software commonality. And people say, well, how can we get your software from the TX2? And the answer is, well, not going to do any good because it's written in a proprietary high-level language, one-of-a-kind computer, whatnot. So, and then in parallel with all this stuff, there's a sort of a euphoria going on in the Boston area about companies starting up and startup activity, and some of which was startups leaving Lincoln Labs, Digital Equipment being one that had left much earlier, but it was quite a success story, and then there were others that were leaving. And there was a professor by the name of Ed Roberts, who taught at the Sloan School at MIT, who came out and gave a lecture to anybody who wanted to go at Lincoln, and talked about the success rate of startups that left Lincoln and their success rate 5 years after they left. And it was 80% success, where people were still in business. Wow. So those are pretty good odds.
Yeah.
So
interesting. I've been very interested recently in the whole startup world in the 60s, what that looked like. So I'm very interested to hear their recounting of that. There was a company called Vitron that got funded, and eventually at $200 million. It was going to be a key punch replacement. In Boston, there were two key punch replacements, Inforex and Intrex. There are a bunch of startups going on. So we sort of had lunch together. There were four of us that would sit and have lunch and say, well, what could we do? Why can't we go start a company? And it was me, it was Harry Lee, who's a PhD from MIT, Gary Hornbuckle, who had a PhD from Berkeley, and Dick Spann, who was a PhD from MIT. So all about the same age, all married, all with young children, all had mortgages, And so the question was, what could we do? Build a paper tape reader. Do you want to do this? Mag tape machine, whatnot. And so the notion was, well, we ought to stick to our knitting. We ought to do something we know something about, as opposed to go out. So then Harry Lee went off and spent quite a bit of time and went down to the Harvard Business School and in the Baker Laboratory, Baker Library, and did a bunch of research. And he devised a business plan, and we were going to have four products. We were going to have the design assistant, which was the graphics, and then a digital circuit simulator, an analog circuit simulator, and an analog synthesis program. The last three programs were all software running on timeshare. All this was expected to be an advantage because you didn't have to buy machines to run them. You could use commercial timeshare. And but the graphics had to be on a dedicated machine. So Harry... And the graphics, again, was for mask layout.
Mask layout, printed circuit board, mask layout.
Okay. Was the principal target printed circuit board, or...?
A combination of printed circuit boards and integrated circuit masks.
Okay.
And so Harry, his wife was in medical school, and he went to a graduation party for her and met Peter Grace of W.R. Grace Steamship Line. And Grace's son was graduating from medical school. And Harry walked up and introduced himself to Peter Grace and said, "I'm here to make you a wealthy man." And of course, Grace said, "Tell me more." So we ended up with a face-to-face meeting with the four of us and four senior vice presidents from W.R. Grace. Now, the backstory on W.R. Grace was that he kept wanting to expand and get out of, add to businesses that were beyond, in addition to his core business. So he had bought 49% of Miller Brewing in the mid-'60s with what he thought was the understanding he could buy the rest of Miller Brewing. And a family member owned 2% and wouldn't sell to Peter Grace. So he turned around and sold his interest and made 3 or 4 times his money in a very short period of time. So he knew all there was to know about venture capital.
So I'm particularly interested in this area. What was W.R. Grace focused on at the time?
They were a steamship company.
Okay.
There's a 100-year-old. They were chemicals. They had a chemical plant in Cambridge. They did material building products. They were one of these multi companies. Lots of interest.
Okay.
They invested in
nothing in high tech or
no.
it's
We
all
were the first and last high tech investment they made.
Okay.
So our business plan called to raise $800,000 for a sixth of the company, which is a pretty rich valuation. And so we met with the Grace people, and they went back and said that they were going to make a recommendation to the board to make the investment. And they were prepared to make an advance $100K loan so we could get started. So we said, well, when's the board meeting? Well, it's this month. So this is in middle of summer, June probably. And our investment didn't make the cut for that board meeting. It didn't make the cut for the next board meeting. So in November, they called and they said the board won't agree with it. And would not. So by that time, they'd advanced us a $100K loan on our own signatures, which violated one of the rules that you're not supposed to sign up personal.
Right.
And our reaction was, you don't understand. You don't get the story. So we got an appointment and went to New York and actually had a hearing with Grace himself and some of the senior people, and told the story again. And they reconsidered, and what he had the $100,000 they'd committed to us, and he had a way to get us $300,000 for a total of $400,000 without having to go back to the board. He didn't want to do that. So we said half a loaf's better than no loaf. We'll take it.
So what was $800 supposed to get you to?
Profitability.
Okay.
For all four products.
That was to be everything you needed, right?
Right. Little did we know. But by that time, we'd staffed up. We had staff for all four products. We picked the IBM 1130 computer for graphics and a storage tube. Tektronix had just introduced the storage tube display, and we picked a local supplier that took that display and integrated it into a workstation, and then they had a tablet, so that we had a tablet, a keyboard, and the tablet was the graphics interface. And we thought the IBM 1130 made sense because people could rent it, and it's so we wanted $50,000 for the software, and the terminal was another 15 or 20. So a pricey package, but less pricey than any other of the alternatives that were out there. And then we sailed through 1969, and we said, well, we'll go and raise the other $400,000. We've given this commitment. Surely we can find somebody. And so Gary Hornbuckle did the most of that, walking up and down the streets, knocking on doors and whatnot.
Yeah. So what was the environment there? I mean, were there many venture capital?
There were a half dozen. There were guys that were doing investments. We learned that they didn't invest in software companies because the assets walk out the door every night. Never mind that Cullinane was a freestanding software company that John Cullinane had done for himself, mind you. There are all sorts of reasons why they wouldn't invest in us. So,
and the venture firms at that time, did they have? Were they prepared to offer anything but money, or
they wanted to be on the board. They wanted representation. None of them had expertise.
They didn't have. They were relatively new at that time, I presume, right? They didn't have a long.
American Research and Development (AR&D)
was
the granddaddy.
Right.
Was George Dorio out of the Harvard Business School. Those guys were there. They formed. They left him and did Greylock, and there are all sorts of people that had. Tucker Anthony spawned some venture guys. There were a lot, wealthy families. So there was money to be had, but we were so out of the mold in terms of clearly no experience, no business experience, and software as the principal line of business. So we talked to United Shoe Manufacturing were looking to expand and get out of the shoemaking equipment business, and they needed computers for that, and that was a non-starter. And
I was asking because my observation from what research I had done was that these companies thought it was a way to make money, but they didn't really, many of them anyway, and AR&D was different, but didn't really have expertise in terms of being able to...
AR&D invested in digital equipment,
right,
to make circuit cards.
Yeah, because they wouldn't invest for computers because
Right.
everybody was
And Olson-
losing in computers at the
Olson
time.
had to do computers on the sly,
Right,
and it apparently surprised Dorio when they actually started
right.
producing them.
Because at that time, everybody was failing trying to compete with
Right.
IBM, so they wouldn't fund a
Right.
computer company.
And the digital equipment, all the computers at that time had no software. I mean, you literally had to write your own operating systems, and that's where the universities, graduate students pitched in and did things like that. And that's part of where SHARE came from, which was part of where the Design Automation Conference grew out of, is sharing software for that milieu of computer. And so we just struck out. And so we said, well, it was a little bit of a Waterloo, and so we had success. Harry Lee had gone to a electronic circuits conference in Cornell in the fall of '69 and met a Japanese guy from Matsushita, Dr. Akiyama, who was significant contributor to Matsushita in their semiconductor areas, that he was a fellow, and so he had sort of a carte blanche. He came to this conference to study and try and find things, and Harry made friends with him, and he came through Boston on his way home, and we showed him the movie. We didn't yet have a demonstration, but we showed him the movie, and here's what we're doing, kind of thing. And he went home and said, I'm going to buy one of these. And what helped him make the purchase decision was that they had an 1130 at home. So it was just a software and a display package.
Right.
And what I didn't learn, I knew it at the time, that they had to get a license from the government to export dollars. That was still hard. The dollars were hard currency. The government was just very tight-fisted. And so we signed a purchase agreement with them. We had a irrevocable letter of credit, so that once we shipped the stuff, we could get our money. And then they had to go through the paperwork with the Japanese government. So that was just slow. So this is in 1970, and then in the spring of '70. So one of the things we did was the graphics thing. Is nobody knew what the hell you were talking about. You're going to do this and see these pictures, and
Right.
So we always had something to demonstrate. It was crude, it was basic, but we could show the concept, and so you could either see the lights light up or not. But so, and our notion was, you do construction using the computer. You don't, maybe you do a cell design and transfer it, but you don't sit and do large drawing tables and drafting and then transfer it to RubyLith and all that, which was the way it was done.
Yep.
And which, we learned about being pioneers. We learned about early adopters. We learned about bell calculus. We learned all that stuff just by doing.
Right.
And fortunately, we had made a demonstration to General Electric's research group. They had a fledgling semiconductor fabrication up in Syracuse, and they saw semiconductors as a way for them, as part of the computer business. It's also a way to put electronics in appliances, and they made a terminal at one point, some years later, called the GE Terminet, that had 22 MOS packages in this terminal. Just a keyboard. But so we showed them and got them excited. We went up to Syracuse and talked to the brass, and got some people really lit up about, they said there's only one thing, is we can't buy an IBM. Well, okay, that is a problem. And 6 weeks later, they called and said, well, we just went out of the computer business, so we can buy an IBM. So they were our among our second and third. Our first customer was Matt Schuster. We had a customer by Western Digital down in Los Angeles area. That name still exists.
Oh, yeah.
And then the guys at GE Syracuse. The GE Syracuse was the first stateside delivery, because we delivered that on an IBM 1130.
Mm-hmm. Now, at this point, did you have all the output formatting to go directly to a MAN or some other?
David Mann and CalComps. You could plug a plotter in and output to that, but that was it.
Mm-hmm.
And
everybody that was buying that time was buying for IC design, right?
Right. But the GE was an early adopter for printed circuit board. They went whole hog. It was a military division, and they had 6 Applicon systems by 72, 73. But it's very clear that the economics were distorted by this IBM, because this IBM was $110,000 worth of computer hardware. And at that time, then, you had Digital Equipment launch the PDB-11, and Data General launched the Nova. So prices plummeted. You could buy an OEM version of this. You could put more of your own value added around. So we decided to be in the hardware business. We sort of tiptoed into it in the sense of buying PDP-11s, and we actually had an industrial design person design for us a workstation. So you had a desk, tapes here, computer screen here, keyboard and laptop, keyboard and tablet, with the computer and all the guts down here. So, and that was $70,000 was our price, including the software. So there some head snap. They started getting some attention for that, and Western Digital bought that one. It was the first guy to take delivery of one of those. We probably sold 6 or 8.
So where were you financially at this point? I mean,
you on fumes.
And you sold to Mitsubishi, but it sounded like you didn't get any cash out of them for some time.
Well, we collected the cash for Matchust in advance.
Oh, okay.
I mean, when we shipped the iron, but we cut salaries, we laid off people, we discontinued all but the graphics, so we laid off all the people that had been working on these other programs, and kept some of the people and put everybody to work on doing integrated printed circuit board applications.
So how far along did the other products get, the simulators? And
we had them running. All 3 of those products you could demonstrate. I mean, you demonstrate them with a teletype on a time-shared computer.
Right.
So again, there's a leap from seeing a schematic on your drawing board and to doing all that you need to do to simulate it.
You had to enter the net list and
manually,
and then simulate.
Right. So all of which was a
stretch. Were you out trying to sell those products? And
we were.
And they just weren't getting traction?
We hit the recession of 70, 71, and basically engineering departments didn't have any expense money. So buying time-shared computer times expense, buying software, paying for software on a rental basis was expense. So they just said no. I mean, the only place there was money was capital equipment, and at that time you could capitalize purchases of software as long as it came with hardware.
Right. So you were in the capital equipment business.
Yeah. And by necessity.
Right.
So we generated enough excitement in General Electric that they said, hey, we told them we were looking for money, and they said, hey, we've got a venture capital arm that's run out of corporate. And so they sent around a guy who looked at us and said, nah. So we called our friends in Schenectady, and we said the answer is no. And they said, well, maybe he didn't ask the right way. So they called back, and they came and basically envisioned a 2-part investment of, I think it was probably $200,000 and $200,000. And we all had to take salary cuts. We had a buyback agreement between the founders for we had equal shares, but we had a provision if somebody left in the first 3 years, you had to sell back a certain amount.
Yeah.
They made us extend that, and he came on the board. And there are 2 GE people came on the board. Mm-hmm. So, and then they had a condition that we hire an accountant, because Gary Hornbuckle, who was president, was keeping the books, and all the financial reports were run on the IBM 1130, and he was probably 3 or 4 months behind in terms of generating an income statement or balance sheet.
Right.
We knew where the cash was, but
that's all that mattered at the time.
That's right. So he had to get out of that business. We had to have somebody who had an accounting background, and one of the GE guys had an accounting background, so there was a fit there. And the expectation that there would be another tranche of money coming, and hopefully get somebody else on board.
So how many people did the company?
Probably 12, 15.
So you're trying, what was the biggest? I mean, what were you trying to do 4 products with?
We were probably 25 or 26, and then got down to 8 was probably the lowest number. Secretary, 4 founders, and 4 early, 9. And a sales guy, we had 10. So,
were these all young programmers that you hired?
And again, the connection with 3 of the very personal connection between Harry Lee and 2 of the people that had come to work on the analog stuff, and then digital. Dick Spann had supervised the thesis of Rich DePice doing digital stuff, and he had come to work on the digital simulator. Mm-hmm. And then Walter Anderson, who'd worked with Harry Lee at MIT, came to work on the graphic stuff. And so those hires, and then Phil Carvey had worked with Harry Lee. So Harry was instrumental in getting 2 of the first team. Dick got 1, and then we were very fortunate to find one, the guy who wanted to leave Raytheon. Mm. And the resistance about joining a startup, particularly a startup that's just clearly bumping along, was pretty high. I mean, just you had to be. We hired some, as we sort of made progress. We had women software programmers, and they could do it because their husbands were employed, and. But that was, it sort of came and went. And there was a sales resistance in terms of getting people on board. I mean, once we had the graphic stuff running, then you could generate some excitement about, you get to work on this neat, fun stuff, and here's what we're doing, and so that helped. But the startups were just out of the, nobody understood them. So. We then started shipping the PDP-11 based system. We shipped one to Western Digital. We shipped one to General Electric in Waynesboro, Virginia. We shipped and these were hand built. I mean,
and you had to rewrite all the software. Right?
Yeah, we just started over, basically. But we started for cost reasons. We said we could only have 16 kilobytes of main memory, because 4 kilobytes was. Or 8 kilobytes was $5 or $6 grand. So you throw the economics out of whack. So the software guys we all just screamed, "No, we can't do that." The answer was do it. So we made it all fit in this it was 8K, so 16 kilobytes. And it all worked. Everything was paged off. We had a hard drive, so everything was paged off that, and it was reasonably responsive. You could build some pretty interesting circuits. And we knew we would bump our head, and then bumped our head in about a year, and basically had to go back and retrofit everything we'd sold with another 8 kilobytes, and expand the software to give ourselves some realistic. Right. But we sat with that. 24 kilobyte limit for 4, 5, 6 years.
24 kilobytes, wow.
All in assembly language. Well, the operating system was tiny, because all you had to do was manage a keyboard manage the
display
and the tablet. You know, the real-time inputs were the tablet and the keyboard, and the I guess it was a real-time feedback for the display. So 15 or 20 words worth of operating system. So we basically started selling that, and we got the second tranche of the GE money, and then in '74 attracted J.H. Whitney. And so that was a bigger tranche. I don't remember how much money they invested. But we were also selling stuff so that you had the extra cash in the bank, but you also had the revenue. We were bumping along break even. Nothing, no great shakes, but
right.
And in about 74, 75, things started to open up and for the electronics. And at the same time, then we felt that we needed to be able to address three-dimensional applications. And rather than just say do drafting, which is what computer vision was doing, we made 3D models, of wireframe models of 3D things. And that
now this would be for totally different applications.
Automotive,
automotive or architectural or whatever.
Whatever. Right? And again, it's a leap. It's one bridge too far. It's, you know, if you had to do it over, you'd do drafting, because that was the money application.
Right.
But
so what was the competition at this point?
So computer vision had started about the same time, but they did not focus on, they had a product, they had 3 products they started with. One was a tester for integrated circuits, one was a photomask imager for printed circuit boards, and one was they called it the Interact. It was a big board that you digitized something and pushed a button and it'd be plotted back. So basically creating, and that was to a time-shared computer. So we kind of were the existence proof for them and for Calma in showing what you could do with a mini computer, and you know, connected to a graphics display. Calma was selling digitizers, and again, digitizers into the integrated circuit market, where you make a drawing of the photomask, and then you digitize the polygons and output that to a tape. And the notion of, oh, you might need to fix an error, or you know, so that all fed into that.
So, as I remember, the digitizers were popular because they didn't have to invest, they didn't have to sit somebody interactively before this $60,000, $70,000 workstation, right? Well, so they could do their hand drawing and digitize it, get it electronic form that way.
But you see, all the workflow methods in the late 60s, where you make the drawing and then you transcribe it to Rubylith. You cut Rubylith and then peel it. So you transfer a layer at a time. So, and that was done manually.
How exactly was that? I mean, it was...
Basically, you'd lay the drawing, you'd make a scale drawing, lay the Rubylith on top of it,
and cut the Rubylith,
use an X-Acto knife and cut either the red or the white red out.
Yeah, right.
Okay, so that's the methodology that they were using. So, and there are guys that said, I don't need an automation, you know, I don't, you know. So
Calma at least solved the Rubylith problem.
Well, Calcomp solved it, because they had a Rubylith cutter knife for the plot. So they had a flatbed, and you hang a tape and drive this knife around, and you could cut the Rubylith, and then you could peel it. You still had to peel it. Yeah. And that's where the input. So the Calma guys came from Calcom, and that's they did the digitizer, and then they could see that connection. So.
Right. Okay.
But they didn't offer a tube until well after, you know, we were out there with a tube.
But that still was an easier adoption path.
Right. Then that's
because it sort of fit in their methodology.
It's the way we've been doing it always, and it's just a slight wrinkle instead of, hey, here's a dramatically new way.
Right.
And so, but then we ventured into 3D and started doing that, and got a big sale with General Motors. Was an early sale there. And but tough, again, a pioneering kind of sale. We weren't doing drawings, you weren't drafting, you were conceiving of objects that were the database.
Yeah.
And in parallel with all this, we had the VLSI, we had the Moore's Law breathing down our necks, and we used 16 bits to represent positions on the integrated circuit. And that's fine until the circuits get beyond a certain size, and you need something larger. So we had to bridge the hurdle to go from 16, and we decided to go 16 to 32. And we did that with a completely redo, start from the beginning and redo it. And this time we did it Fortran using an IBM PDP 1130 and we had the competition in the integrated circuit world was Calma, and they had their claim to fame is their display rate was faster than ours, and we could never figure out why, but it was. So we attached a processor, a graphics processor to the PDP-11 with the notion of being able to drive the storage tube. I mean, by that time we had a 17-inch storage tube from Tektronix. And so a little bit better. And then we got into TVs, monochrome TVs, and then color TVs. So that transition from storage tube to refresh to color refresh happened in the mid to late 70s. And you got, the color workstations were more expensive, but we were also had an ability to timeshare off of one CPU with the new VLSI software. So you have a $90,000 workstation, $350,000, $400,000 worth of system all told. And we got a big order from Intel that sort of helped.
Now Intel had been a Calma customer, right?
Yeah, right along, and they still were. I mean, the guys up in Oregon, Bill Lattin was instrumental in making the decision and making it work. And thank God for customers, because we had some of the most patient, demanding, but they worked with you. They knew they had a better sense of the struggles we were having than we did. That how early we were and what the issues were, and they were all smarter than we were.
So, did you continue with 3D stuff? You said you made a big sale to
GM
General Motors
and others. Big pitch to Boeing. There was a big shootout between computer vision and Boeing for the 757, 767 design. Boeing had a disastrous ECO problem with the 747 in terms of changes and keeping track of changes, and they had a corporate goal of reducing that, and they wanted CAD software, and so it was between us and computer vision. And computer vision software, computer vision had licensed their software from Dave Albert's company, the Handready software. And so they had it in, quote, Fortran. Ours was still all machine language, and then that was one of the deciding factors of why Boeing went with computer vision rather than us. So, and we also we struggled with management issues. So the founders, Harry Lee left in 73, 74, and then Dick Spann left in 76, and the company was struggling, and our board of directors decided they needed a new CEO, and so they replaced Gary Hornbuckle in 78.
Yeah, so you talk about the founders, but what were their respective roles?
So I was always in charge of what we call the design assistant, the graphics for, and I wore a lot of hats, as you do in a startup, and but my job was to make that go forward. And Dick Spann was to supervise the digital circuit simulation. Harry Lee was to supervise the 2 analog products, and then Gary was boss. And when we had to collapse, then Harry Lee, this was in 70, 71, Harry Lee went to Chicago to set up a sales office and sell the product, the graphics product, and then Dick Spann took one of the fellows with him to be an application engineer and came to the Bay Area to sell the graphics. So we were up in had an office in Menlo Park. and rented. I mean, this was early enough that we rented the time on an 11:30 in those guys' office until we could get our machine on the PDP-11 up and running and available for demonstration. And benchmarks were just the name of the game. Now nobody would, because our background had been ECL, nobody believed you could design MOS circuits. You know, they're just rectangles. So show me the MOS circuits, you know.
Yeah.
Okay, so you had to do benchmarks for everybody to prove that you could do an MOS circuit. And so that's why we had to have somebody in the West Coast, and you had to have, we could travel with the PDP-11, the IBM 1130 software, because you could go and rent a machine somewhere and take a terminal and go. But once you have the PDP-11, then you had people had to come to see it. So that's why we had people, you know, demonstration in the Bay Area, and people come down for do all sorts of benchmarks and things.
Right. So, you clearly had significant market education work to do up front.
Right.
When did that become sort of obviously much easier? Was it sort of a gradual change?
Very gradual. I mean, it took major adoption by General Electric in a facility, by Intel in a facility. Intel outfitted 3 or 4 different sites with our the VLSI, the second generation IC stuff, and we're committed to making it work, and did make it work.
And so tell me about the growth and how that, you know, what the next steps were and what.
Well, we sort of grew in fits and starts. I mean, we were able to keep bumping along at break even, you know, but we were didn't have any extra money to spend on anything, and when we did get money, we end up spending it on got some money, and then we invested in a color inkjet plotter, licensed technology from a guy in Sweden, Helmut Hertz, of some relative was the Hertz that was named the electricity is named after.
Yeah.
And it was a drum printer, and the notion was you could print proofs of your integrated circuits. Well, that's true, but you got to generate a magnetic tape, and you had to rasterize all this data that you basically kept in graphic form and in
vector form.
Vector form, and get it rasterized. And you tried to do that in a
PDP-11.
PDP-11 with 24 kilobytes and shoehorn that in with everything else just was a non-starter.
Right.
So we never got that. And it's an obvious connection, and you say, why the hell didn't you do it? Well, you had to have a dedicated PDP-11 to do it. It was just that big a problem.
Right. So is this a good time to sort of look back, or do you want to sort of continue on?
Well, let's get through to the IPO and all that stuff. So I talked about Harry leaving in the 73, 74 time frame. Dick Spann left in 76. New CEO came in 78, and Gary Hornbuckle left. You know, we don't need 2 CEOs.
Right. So you said the board, you know, sort of forced him out. What was the board actively involved, or you know, was it, you know, did it offer any good guidance, or just things are going bad, we need a new CEO?
Things are going bad. It's just one of the Grace guys had done chapter and verse of missed milestone after missed milestone, you know, financial milestones, and said to his colleagues on the board, you know, it's clear this is what's going on. We need to make a change. They picked up a guy, but I mean, let's.
You want to take a break?
Yeah, I just got to get a cramp.
Yeah, go ahead. Let's stop.
So the board reviewed performance of the team and said we need something new. And one of the board members had been a investor and director in a company called Intrex that was close by and was made software and hardware for key to disk. And they had been bought by Nixdorf, and the CEO had left that. It was available.
Right.
So it was an obvious fit. He got interviewed by the directors, showed up in April of '78, and then started to realize how much of a mess he stepped into and brought in a number of people he'd worked with, people he could count on personally that he'd worked with at Intrex. And he brought in a VP of marketing, the name of Dave. The CEO's name was Don Fedderson, and Dave Barber was the VP of marketing, and basically is energized and did a great job of sort of picking up the reins and selling the products we had. And that's at that point we started to really start to take off, because we had he recruited a sales team, and we had in place energy and drive behind selling what we had, and Dave did a marvelous job of managing that, making it happen, and Don's, as CEO, gets some credit for all that. And then they brought in a guy as chief financial officer, again from Intrex. A number of people came over, software developers came over from Intrex, and I was still nominally in charge of software development. And these guys looked at the application, and they said, "This can't be that hard." They're used to moving text strings around in database. I said, "Well, why don't you try it?" And they didn't. They just thought I was being an old fogey and stuck in my ways. And they tried some ambitious things and kind of ran afoul of their own. They basically launched the idea of a brand new product that does everything you've always done and more without the integrated circuits. The integrated circuits got separated, and we kept going with the existing product, and that's what paid the bills. And then, so to do printed circuit boards and 3D designs and all that stuff, you need something new, something different. And
so that's what they launched off into.
Right, and it captured a lot of people's attention. The company went public in 1980. Very heady evaluation. It helped that General Electric, having owned a portion of the company, we teed up to go public, and they came to the company a week before the IPO and said, "We'd like to acquire you." So you had to pull the IPO, and the deliberation was thanks, but no thanks. So the IPO comes back at a much higher price. So, and then they had to figure out how to get General Electric out of the company, because they were going to buy Calma, because that was the only other game in town. So they bought Calma after that. And so public security, quarterly earnings, all that stuff. I left. I was fired basically in end of the IPO was in the summer of '80, and I was told to pack my bags in November of '80 and left there. So, all right. So let's now look back. And so, what were the lessons learned? What was the lessons learned was the second system is a generic problem across the industry, and it was a huge problem. This notion of replicating everything. I mean, we'd done it in the integrated circuit world because we had gone from assembly language to Fortran, and because it was the application is straightforward, and we sort of knew where the bottlenecks were, and you knew you could replicate the functionality and do what needed to be done in a pretty well-defined course. But if you're going to then and try and do something similar for printed circuit boards, for drafting, for all these applications that are much broader, excuse me, you're pushing a big snowball uphill, and there are companies around the valley, around out there, that have tried to do a second system.
So the second system you're calling what they tried,
what they came in and tried to do.
The transition from like the 1130, you had to rewrite all the software to go on the PDP-11, but that was, you didn't make the mistake of trying to over-enhance it. You just sort of moved it.
Got it going.
And
it took us 3 years or longer to implement. I wrote a specification for what the software was to do, and it took us about 3 years to get it implemented. I mean, they wanted to see circles on the screen for printed circuit boards. Well, that's a pretty unreasonable thing. You know, we showed them squares and said, imagine a circle. Which they did for a while, and we got around to doing circles. It's the second system problem and a scope creep. You know, you specification change, things get added, you know, things blur. You can never get it nailed down, and I think some of that. I mean, I was gone, so I only know from hearsay.
But going back to you know, the time when you were just starting up the company, first you started with 4 products, and it sounded like, you know, in the end, it was one product that was really carried the water.
That's right.
And so
very quickly.
And so you were overambitious, and you know, do you think you were?
I think naivete and not knowing what would sell.
Yeah, in terms of understanding how difficult the adoption process would be.
That was a huge thing. Right.
It was so cool. Why wouldn't they just take it? Right.
Right. And you're just up against guys that have been doing things a way, and you're saying change, and you know, harsh language to follow.
Right. Familiar with all these problems.
Well, you know, there are all sorts of guys subsequently who have the same sort of issue. I mean, every time somebody's tried to introduce a programming language to do circuit design, oh, I guess that's what Synopsys did with the synthesis.
But they were very clever in the sense that they first introduced it as a logic optimizer, not as a synthesizer. So you could draw your logic and then
input it,
and it says, oh, it made it better, and you could immediately see what the benefit was, so
they thought about the adoption problem.
I don't know whether they thought about the adoption problem or they just got lucky and worked, you know, did the first obvious thing. But the result was that people could buy the product and get value out of it before they had to trust it to create things from, you know, whole cloth.
Right.
And they also didn't, you know, the other major problem in terms of adoption was that there wasn't, you know, you had to enter it in some language. And so the, you know, Verilog coming along, you know, was a huge advantage to them. So I think they got lucky on some of that, and there may have been some wisdom mixed in with the luck, but
hey, you always claim it's wisdom.
Yeah, exactly. I'll take luck any day, right?
I think on that luck aspect, we were very fortunate in the customers that picked us and chose to stay with us and work through thick and thin, and you know, part of that is we were. I mean, the people in Syracuse called because one of the stylus for one of the tablets had broken, and they called on Friday afternoon, and I said, well, the way we can get one there is I'll drive one out to you. So I jumped in the car and drove 320 miles to Syracuse and delivered it, and you know, they're back in business. So that kind of the involvement of the founders and the personal commitments helped with that interface, and there's still customers that I talk to, people who bought from us 40 years ago, or 40 plus years ago that I talked to.
So did you have what was your vision for the future of the company? And you originally had these other products and then narrowed it down.
Right.
I
really thought the software had longer legs. I really kind of bought into the software vision of, you know, this thing extending across applications and doing more things, and other people wanted more. I mean, that was very naive in the early days because nobody else was doing it, you know, and this issue of the software assets walk out. You know, you don't have anything on the balance sheet that represents the investments you've made in software. But I wanted to have a big drafting table that was a CRT, something that you could work on and visualize stuff and interact with it. And we're there now.
So in your view, you were in the graphics business.
Yeah.
You are not in the IC design business, or
We were in the applications for graphics. Yeah.
Right.
Yeah.
So
But
you didn't go looking for what eventually Daisy Mentor Valid pursued
Right.
in terms of design capture.
Our argument was we have a database, and you can interface the database and do design rules. You can do all sorts of things off of the database we've got, and that it solves some of the purchase objectives. People saying, well, how do we get at what's in there? One of the purchasing objections was, how do we know? What do we do if you go out of business? How are we going to protect ourselves with your software? So
Right.
we had to put escrow agreements and put software up. How do we get at the database? How do we use the database for rules check or this or that? And the answer was always to come through the database, and rather than us trying to integrate, like Daisy Mentor Valid did later.
And so in retrospect, what path would you have followed, or what was the...
Well, I think that if wishes were fishes, you would have not spent some of the money on the distractions that we raised and used it to keep going forward with the software solutions. Would have worked better. But you can't go back, because you're sitting there and you don't really know how many more of these workstations you're going to sell. Because everybody's talked about Moore's Law, and but is it really going to happen? And what's the proliferation, the having engineers sit with 1 or 2 or 3 workstations on their desk and doing designs as they do today, is you're crazy if you tried to convince somebody that's the way it was going to be.
Right. So just to sort of complete the story, what eventually became of Applicon? You had left in 70...
I left in 80. It was public. It was acquired by Schlumberger in 82, the French oil services company. They had a grand vision for being a presence in the electronic business. They bought Fairchild.
Right.
They bought a company up in Ann Arbor, Michigan called MDSI, which interfaced to machine tools. They eventually merged MDSI and Applicon together, and then Feddersen left at some point in there, and they brought in some people, and then they basically sold it to the Gores brothers, who were sort of liquidators, and then they've sold it to somebody else, and I don't know where it is now. It's a long time.
Yeah, a long time ago. So what was your next step? You stepped out of
I sort of
and
decompressed.
regrouped and
decompressed. I had young teenage children at that point and wanted to see them, and and was pretty beat up emotionally.
Yeah, I bet.
And just said, so I said I'll be a consultant. I'll hang up a consulting shingle, and did some stuff for a guy down in Washington, D.C. that was much more graphics oriented, and the people at Mentor, Tom and Jerry, knew of me through their venture capital connection, also through a guy by the name of Mike Cronin, who was at Computer Vision. And because they'd approached Mike about wanting him to be involved as an advisor in their startup, and so they called me and they said, would you consider doing this? And I said, sure. And went out and talked to them, and we struck it up, and so I was an advisor to the team until their public offering, and they asked me.
So you started in
81.
81. Oh, so right away, kind of.
Yeah.
Right when they were starting up.
Yeah, very quickly after they started up. And then joined their board at the IPO time. They had a 3-man board up until then, and they expanded to 5 people. I think I wasn't tainted as being a venture capitalist. They had two venture capitalists, and they had a guy by the name of Bob Schroeder who had been at Daisy printer company, Diablo, I think.
Oh yeah.
And he was sort of the other rational person, the non-VC, and I was a non-VC.
Right.
And that was just a wonderful ride. I mean, it had some pretty scary moments, and they encountered this second system problem.
Yeah, I was about to say, did you, having gone through some of that yourself?
I just go, and I really wasn't as helpful as I could have showed. They're just because it was so, the enthusiasm for doing the second system and the need was so obvious, and I tried to convince them way early was to build their own hardware, like Daisy
was,
Ballard had done, and Tom just said no. They were stuck on the Apollo because there were the venture capitalists that invested in Mentor were also investors in Apollo.
Right.
And thank God that Hewlett-Packard bought Apollo, because that gave Mentor a place to go at that time. And then they're on, I guess, mostly Suns now, and some a little bit of everything. But and Wally's been there 20 years.
It's been a long time, hasn't it? It's in my conversation with them about the the whole 8.0, the second system thing, it's clear they had to do it. The biggest mistake that they acknowledged was trying to do a new database at the same time.
Right.
Was what killed them.
Doing everything.
They had to make the transition to another workstation. They had to rewrite it, and that was fine. But they should have just kept the same database, as opposed to that was sort of the Achilles heel that really screwed things up.
New and improved database.
Yeah, exactly. Always is.
Yeah, and they had scope creep.
Yeah,
just unbelievably, and
probably across several of them.
You do that when it's late. I mean, you desperate to get sales, and you're selling futures. I mean, we sold futures all the way along.
Futures got to be brighter and brighter, right?
Yeah, and the accounting rules are such that we couldn't have existed, because we were always selling something that was going to be delivered, 3 years from now, and you never could have recognized that. No matter that you were paid for it, you couldn't recognize the revenue until it came.
Right.
So.
So you have made a note here about MIT involvement.
Yeah, I flirted with the mechanical engineering department. There's a guy there who I had known and worked with, and we put on a conference at one point, a CAD-CAM kind of conference that was under the aegis of MIT. And after I got out, we did a second one of those that I was more involved with, and I had some sort of adjunct professor title or something that was sort of a hunting license. And what I realized about myself is that I have a speed that's different than the academician.
The academic speed. Yeah.
And that's part of what led me out of Lincoln Laboratory is that this, I want to get things done. I'm in a hurry about lots of stuff, and it gets me in trouble, but some of the stuff gets done and turns out to be pretty good. So. And the guys at Mentor had a wonderfully strong sense of urgency. I mean, they demonstrated their product at the first DAC that had exhibitors down in Florida. Yeah. And
they acknowledged that it was pretty
hairy,
lashed together.
Right. And they worked several sleepless nights to get there. But that's how you get stuff to do it.
Yeah.
You can't. A friend of mine, a fellow that had come to Applicon and worked and was a mainstay in terms of getting the 3D system started, and was really a solid citizen. And he came out here. He was out here to sell Applicon systems. He sold IC systems to Intel and got that. And then he did a startup, and his founding premise was you only have to work a 40-hour week for a CAD-CAM startup. I said, okay. And I don't think it panned out. I mean,
good luck with that.
Good luck with that. It didn't work, and he's back. He works for MathSoft now, and has been back, there for quite some length of time. So he's fine.
So you've also been involved in some private investments, some venture capital kind of work?
And I was in a formal venture capital fund in 83 and 84. Joined in 83 a firm local to Boston called East Tech Management Company, and we raised a total of about $35 billion over 3 funds. And the notion was Eastern, local to Boston, early stage investments, hands-on, value-added kind of thing. And that's tough ground to plow. I mean, it's having lived through a startup, and you think, well, there's all sorts of things I learned, but it's all new learning for everybody else. I mean, it isn't. Invested in a company called Banyan Systems that was a network company that eventually got acquired.
Yeah, they did well, didn't they?
Yeah, they did well for a while. They got beat by Ray Norda. Noval was the name of the company.
Right.
And it isn't the product, it's how you position the product and what it is. It's the marketing. It's the insight behind how this goes in the users. I mean, I'm forever wanting to skip 10 years ahead of time. I mean, I privately invested in another inkjet company in 1981, made smaller inkjet printers, color printers, and just hopelessly way too early. It's color everywhere now, but that took a long period of time to get. Right. We used to sell the Tektronix storage tubes, and they said, what about color? I said, you can have any color you want as long as it's green. Just like Henry Ford.
Just like Henry Ford, exactly. So what would sounds like you've had some involvement there with the East Coast. I mean, is there any difference, any way that you would compare some of the East Coast venture firms that you have been familiar with versus some of the West Coast ones?
Well, it's not original with me, but the East Coast and West Coast are dramatically different. So if you go back 30, 40 years at times, think about digital equipment, IBM, computer vision, Prime, Wang, all very proprietary companies. They built everything. They used to talk about Tektronix up in Portland as making their own screws. They're vertically integrated for everything. You come to the Valley, and everybody has got all this supplier network that they've developed. They depend. There's relationships. So you have in the Valley, you have all this relative freedom of information and experience that gets passed around and shared that just doesn't happen in the East Coast. And I think the venture guys in the East are a little. They tend to be doing other kinds of deals now, and the West Coast guys are. Although I say that, the activity in New York City, the activity in Boston has picked back up. There are all sorts of deals being done, and it's typically by the younger members of younger firms. Some of the older established firms are doing deals, but it's the new guys that have had a hot hand and are doing stuff. And I just walked away 15 years ago and just said, it ain't for me. It's not. I can't add any value. I'm out of date. I think the deck is stacked against individual investors because you got all these angel funds that are around and people putting small amounts of money to work, and some of those pay off very handsomely, and a lot of them just end up going nowhere. And
yeah, they're very difficult these days. I was in one as well, and it's become a much more ruthless business. It's so easy to get
overbid,
overbid or washed out in the next round. Unless you have money to continue to play. The pay-to-play thing, and people bringing money in later are
just don't care.
Just don't care. It's just
you're being rude. I know it.
So, do you have any observation on this? Sort of diverts from sort of the main thing, but given that you sort of lived through this, I'm curious as to your observation in terms of, during the 60s and early 70s, there was a lot of startup activity, a lot around mini computers and so forth. I observed that every one of the mini computer companies went away, except for digital. Well, digital did go away. Hewlett Packard and IBM sort of existed before and after.
Right.
But every company that was started to be a mini computer company went away.
Right.
And that was, and you have any observation as to why the Boston area didn't sort of renew itself in that regard? And
You can't step up to eating your children.
Mm-hmm.
That the stuff that the competitive guide Harvard Business School talks about of the well-managed companies fail.
Mm-hmm.
Is that you've got to just be relentless about working on what your customer needs. Never mind what you've got and what you're selling, but how can you do something for the customer that he doesn't, the new stuff. I mean, think about the disk drive progression. And that was all done on the West Coast by startups. Jesse Ueda's company up in Boulder went to the wayside. I mean, they tried to venture into tapes and whatnot. And so I think there's this, Polaroid is a classic example of a company that couldn't figure out how to, and Eastman Kodak in Rochester, same thing. It just the margins on the existing businesses are so great, and some whippersnapper comes in and says, we're gonna start selling this stuff at, instead of a 75% gross margin, we're going to sell it for 25% gross margin, and then get out of here.
Right. Right.
Right?
Yeah.
But that's what's happening. And our son's in the internet retail business. They sell underwear. He and his partner have got they sell men's and women's underwear over the internet. They've 14 years now, and they're doing great. They're doing fabulously. They've got $100 million, and but it's just a business that you keep working on every single cent that goes. What the cost of freight, what's the cost of packaging. It's all this stuff that they have to. And they're in New Jersey, so.
Civic involvement?
Yeah, I agreed to go on a couple of boards. One was a hospital board in 2000, and I thought again, I'm an optimist, and I thought, boy, the time is right for changes to happen in healthcare, and this regional community hospital. They ought to be able to make some things change and make things better. Boy, was I wrong. And I was on there for 8 years. And then in the town of Carlisle, which is a town of 5,000 people, that's very rural. We're out near Concord, Lexington, out that way. And it's a land conservation, bunch of tree huggers. And so they basically raise money and buy land, figure out how to get land conserved as opposed to building houses and whatnot. Right. And I was treasurer for that for 15 years, and that's done. Well, I don't really want my phone to ring and have to have somebody explain to somebody why I'm going to vote against their interest. And life's too short at this point. So.
So what do you find yourself doing these days? What's your...
I'm into family history and family stuff. We've got about 20,000 photographs that I have scanned and captured. I've got another 10,000 to go.
Holy cow.
10 or 12,000. And so I've done all that with the belief that I'll somehow be able to organize it. And I'm now facing up to the issue of this grand scheme of having a database and a Wikipedia and all this sort of stuff is a lot of work to do, and then a lot of work to maintain once you've done it. So I've changed strategies, and I'm into making photo books, photo albums, and having physical books that you can give to the kids and grandkids and say, here's your family history, and with pictures and annotation and stuff. And it's a start. I mean, I'm not very far along the way. I've done a couple of books, but they're very hard to do well, and I want to do them well. So I've got one that's hopefully will be printed this week. We got a family reunion coming up in July, and I want some of this to be able to show and whatnot. So
yeah, I've been involved in some similar things, and it's the whole issue in the museum, and everybody faces it, is the digital storage. And this is not exactly what you're talking about, but digital storage is a everybody thinks of it as a blessing, but it's I think that is a problem that really needs to be solved.
Well, it's getting worse because of the cloud stuff.
Right. And there's just no editing. I mean, it just goes, right. You get 20,000, you don't need 20,000, right? There are some good ones in there.
Right.
That, and before we were forced to edit, and, I also did, gathered a lot of old family photographs. I have some from the late 19th century. And, back then they took one photograph at the wedding. Today people take thousands of photographs at a wedding.
We double the world's population of photographs every year now. Yeah. It's just staggering. And
so just dealing with that volume, and it's one thing is, well, how do you store it all? The second is
why do you store it?
Why do you store it? If the editing is the problem, is what are the few photographs out of those thousands that you really want to store and treasure?
Then you go to the complexity of dealing with movies. We've got a bunch of home movies that are now digitized and in the computer, and we've done some editing of those. But so where do you show it? Do you put it on YouTube?
Right.
What's the issue of privacy around that? How do you protect that? I got family members that just won't let me even think about putting it on YouTube because of privacy. So they're just going to sit in the disk somewhere until we, there'll be some books that they may or may not. I mean, the book software the one we're about to finish is we did with iPhoto, and we do it the Apple way or you don't do it, and we've bumped our heads, and so we're using Lightroom with the book, and I'm more comfortable having it on my computer than doing it in the cloud. We've done a couple of books with Snapfish and Shutterfly and people like that, and that's serviceable, but it's not. You can't get in and sort of do the level of control that. And but there are lots of people that are thinking about this and worrying about it.
Oh yeah.
At this level. So
yeah. So let's wrap things up here.
Okay.
We often ask at the end, people that have sort of been through all these major transitions in technology, what would be, where do you think the opportunities are today in terms of in the technology space? What would you?
I think getting the best education you can get. The math skills and technical skills are just the way it is. And you got to stay current. You got to keep working on things. You can't go into retirement at age 28. You've got to keep developing new skills and thinking about, whether it's thinking about a new job somewhere else or a job within the company you're working in, you've got to constantly be out there. And if you don't, you're just going to get left behind.
You can't prepare for one career. You have to be prepared to kind of renew yourself constantly.
Yeah, I mean, the one career thing, I'm not one of them, but my older two brothers were both, my oldest brother spent 45 years working for Shell Oil Company, and the other one spent 40 years working for Pfizer. And neither me nor my younger brother have that kind of work history. So, and just it isn't. Nobody can talk. I mean, the lament is that the companies. The reality is that companies aren't investing in doing all the training. I mean, you graduate, in my cohort of people, there were guys hired into the GE management training program. And you spent 2 years being trained by GE, and you were moved around. And they can't afford to do that because you do that and then you go somewhere else.
So, right. Okay.